So this is the first prototype sensor that PV has knocked out, codenamed Nico after the bloke who donated his broken distance sensor to the project. So my plan today is to firstly bench test this to check that the responses are correct. I'll show you all of that. And then I'm going to connect it externally to the car, again check the responses with PWIS to see what happens, and then if all that works fine, I'm going to install it in the car and see how she goes. What I'm using here is a little jig that I've made that I use a magnet and some little spacers so it's going to move the correct distance which simulates exactly what the shift rods are actually doing and the magnets on those. So with no magnet in there, you can see it's giving a 5% PWM return. Let's put it in the central position. Okay, so I would be expecting about 50% there. I've got 39. Now, the problem is though that with the sensors that we're using, they're quite sensitive to magnet height above it, and this magnet is not identical to the one that is in the transmission, and it's a different distance away, so we'll see what we get when we actually put it in the transmission, but I'm expecting it'll be around 50% there. I've got 40%. If I move it in this direction here, I'm expecting it to increase, decrease there. So at that far end there, I've got 62%. I'd expect an increase. I'm hopefully in the transmission that should give me about 80% and about 20% down there. That's distance sensor 2. That's about there. Expecting a decrease in that direction. So I'm pretty much getting exactly the same response. This is distance sensor 3, so with no magnet it's giving me 93%, and it's flipped around the other way, so I'm getting about 60% at the central position. I should see an increase as I go in that direction there, 80%, 44%. This is distance sensor 4, so I should see a decrease as I go in that direction, which I am, an increase as I go in that direction, which I am. My initial thoughts on the testing is that everything works in the correct sense. The sensitivity maybe needs to be changed, but maybe a cal might sort that out, but there's only one way to tell, and that's to put it in the transmission. So what I've done now is I've disconnected the normal transmission connection and I've connected the new sensor externally. I've got PWIS selected and the distance sensor outputs, and it's going to be a little bit hard for you to see. I'll just read them out. They're all reading about 12 millimeters at the moment. I've got the standard drive on error with the transmission fault in the car, but we'll see what we get from it. I'll firstly have a look at distance sensor 1. The north polarity, when I'm looking at it for these 3 distance sensors of the magnet, needs to be sitting on this side. And I should see a negative response when I move it to the left, and I should see a positive response when I move it to the right. So let's put it in a central position there. And that is reading 0.2 of a millimeter. So that's really good. That's right on the money. So if I move that to the left, 9 millimeters, I should see a negative response. I'm seeing minus 9 millimeters. That's good. And to the right, I'm seeing about 7 millimeters. So that's very positive. That's much closer than I was expecting. That's pretty close to what the OEM sensor gives. Distance sensor 2, that's 0.8 of a millimeter. To the left, I should see negative. That's saying minus 10. To the right, it's showing 6.5. Let's go to distance sensor 3. In the center, showing 1.8 millimeters. To the left, minus 8, that's really good. To the right, about 9 millimeters. So that's all very positive. Let's go to the other side. I'm going to swap this polarity around, and I should see about a, where is it, about there? Should see about just to the left of centre, about 0. I'm seeing about 2.5 millimetres. I should see a positive increase there, so that's about 5.7. That's about -11. So we'll see that will probably require a cal in the car, but certainly the responses are pretty close to the mark. And because the magnet is going to be a different height, and these sensors are quite sensitive to distance height, and it's hard to measure the strength of the magnet compared to what's in the transmission. The only real test now is going to be put it in the transmission and see how it performs. But certainly initial indications are very positive. So what I've done is I've mounted the sensor, and the fit seems to be really, really nice. Distances to the magnets in each of the positions seems exactly the same as OEM. I've connected this to the car, and I've hooked up PWIS just to see what it's reading. And I've put my hose clamp on the back here so these gears can't move, so I can quite happily move these two shift rods back and forth to see what the distance sensor is reading. And I'll see it on distance sensors 3 and 2. This is shift rod 3 here, which is for first and third. This one is 3, which is for 5 and 7. So in the neutral position there, it should read about 0. They're normally sitting around between plus or minus 0.5. I've got -0.4, about 1.2 on distance sensor 2, it's the largest one, about 0.4 and about 0.7 on the 4 distance sensors. So as a first crack before you do a cal, that's pretty good. I'm not sure what the tolerances are inside the TCU to work out whether or not that is a valid distance or if it's outside of that. But what I'll do now is I'll move each of these shift rods and see what we get. So selecting first, $10.7. So that's, I would expect about 7.5. Let's move that out of first. It goes back to 0.4. Let's select third. -11. So they're all valid signals, but that seems to be too sensitive to me. Let's see what we get with distance sensor 2. So it's 1.2 at the moment. $10.2. And -8. So, sorry, -11.8. So they seem to be too sensitive to me. But we'll see when we put everything together. I'm expecting that from those results there, it will say they are invalid signals and a cal might fix the problem. If not, then obviously we just need to adjust the sensitivity of the hall sensors. Well, it's the moment of truth to see if this thing works. I've put everything back together again. I put the exhaust back on, and so I'm ready to start it. I had to, after I was mucking around with it with the rear casing removed before, had to clear a few codes. Interestingly, with those large distances that we were showing, it showed an error for an implausible signal on distance sensor 2, which is the 5.7, but not for distance sensor 3. So clearly there's a fair bit of flexibility in there. So we'll see what happens here when I start it. I'm expecting that as soon as, because it's in park at the moment, I'm assuming from what I've seen before, it's going to immediately pre-select first. It may spit an error with that, and if it does, then I'll go through a cal and we'll just see how it goes. I'm not sure if you heard before, but when I first started it made a lot of noise, and that was because I forgot to connect the exhaust to the exhaust manifold. So it made a bit of a racket. But in here, on that short few seconds that it was going, you can see it's gone and pre-selected first. That distance there of 9.3 millimeters is like about 2 millimeters more than what it was before with the OEM sensor in it after the cal had been done with the OEM sensor, and still it's happy with that, which is interesting, which tells me there's quite a bit of flexibility in the distance that it can read before it starts to spit an error. Right, so let's try again. I'll start it and we'll see how we go. That sounds more like a car. So what I'm going to go and do now is go and select first, or sorry, I'm going to go and put it into drive, and that'll select first, which it already has, but it'll also select second. So we'll see if that gives an error. So that's showing a distance of 8 millimeters, which is fine, so it's happy with that. So I'm now going to select reverse. And there's no error with that, so it's happy with that distance. That's really interesting. There we go. So I just completed the calibration without any problems at all, which is great. So what I'm going to do now is start the car again and put it in rolling test mode and run through all the gears, see if she works okay. Okay, that's reverse. Second gear. Third gear. Fourth gear. Fifth gear. Sixth gear. So it's running through gears 1 through 7, 5. Well, I finished all the initial testing on the first prototype. Got a whole bunch of super valuable data from it, and it's interesting in that whilst initially I was a little bit disappointed that it didn't work perfectly, it was pretty close, and the fact that it was marginal, we've learnt so much about when it fails, when it doesn't, the sensitivity of it, and interference from the other magnets that created a difference in the output when an adjacent rod was pre-selecting and that sort of stuff, as well as when I replaced the OEM sensor back into the transmission. I didn't do a cal. We got a whole bunch of errors there, and we've learnt loads about, well, we think we've learnt loads about what the TCU is thinking, what it's looking for, which is really helping us in the future. So PV is working on changes to the second prototype at the moment. In the meantime, in the couple of weeks that it's going to take to get that, I'm going to do a bunch of stress testing on this one just to see what I can do to try and break this thing. So I'm going to do a bunch of heat and cold testing. I'll do some vibration testing, some shock testing, and we'll see how it goes. The temperatures on this 3D plastic and also the potting on this one is different to what we think we're going to use for the final product. This stuff's good to 175 degrees Celsius, which is what the sensors are good to. We're going to put different stuff. Obviously the housing will be made of aluminium. We're just using the plastic for the moment for the testing because it's much cheaper to do one-off shells like this out of 3D plastic rather than like $500 a pop out of aluminium. and the potting itself will also be a much higher temperature than what this is capable of. So I'm going to see what I can do to try and kill this thing. We'll see how we go. Oven's preheated to 175 degrees, so let's just pop this in for an hour and see how she goes. So here's the sensor after an hour in my oven at 175 degrees Celsius. I suspect my oven's a little bit hotter than that. The 3D printed casing, this plastic is supposed to be good to 175 degrees, which is why I use that number. And you can see it's just looking a bit sad. The sleeve in the front here for that front hole, it just melted and just fell straight out. And all this stuff is sort of just melted off in strands. Some of the wiring, the insulation is just all melted off. But what we'll do is we shall see if this tests okay. Of note, the epoxy potting in here that we are going to use is going to be, like, this stuff's supposed to be good to 175 degrees, and there's a few cracks and stuff in it, but for the most part it's held up pretty well. We are going to use a higher temperature version of this stuff in the final sensor, and also the casing is going to be aluminium. So don't take too much notice of how this thing just looks like it's pretty much trashed itself. It's more, for me, the testing of the sensors and check that they all are good to go. So let's have a look at that. So the first thing I'll do is I shall check distance sensor 4, which is a yellow wire here. It's giving me 5%. That's in there. So let's see. There we go. So it still seems to work all right. That's a bit nuts. All right, let's just roll this over. Right, let's try distance sensor 2, which is the white one. Distance sensor 2. There we go. That seems to be working fine. Distance sensor 1, which is the green wire. There we go, that's all fine. And distance sensor 3, the grey wire. There we go. Unreal. So obviously the sensors themselves are pretty resilient with respect to heat. Well, I've had the sensor in the freezer overnight. I'm not sure how cold my deep freeze gets to. It's probably minus 20 Celsius or so. So we'll see if it works. It should do without any problems at all, because it's well within the spec. This is distance sensor 4. There we go. That's working fine. 3. It's fine. Distance sensor 2. Fine. Distance sensor 1. There we go. So they all work fine. This is what I'm going to use for my vibration test for the sensor. It's an old chainsaw that I don't use much very more because it's so rough and unbalanced. It's about 20 years old, and whilst it's a good rescue saw, it vibrates like absolute crazy. So it's going to be a pretty good test for this. So what I'm going to do is run it maybe for about an hour or so. I've had a bit of a play with it. I'm going to strap it to the handle. I'm going to sit it on the top, rev it, because at low RPM it shakes like crazy. But at higher RPM it's just really, really aggressive, the vibration. You can't really see it, but you can't touch the cover or anything. It's just so uncomfortable. So I'm going to do that, and that at higher RPM would simulate much more closely to the RPM that the engine and transmission would see, albeit this is going to be far more aggressive than I suspect it's ever going to see inside the transmission. But we'll give it a go, see if it lasts. had the sensor on the chainsaw for about an hour or so in different places, different RPMs. When I sit it on the top and rev it like that, the vibration is just so aggressive. It's really hard to hold. And this thing, it's a bit hard to see in the video, I guess, but mate, it is hardcore. So if it can survive that, there. I think that's actually a pretty good test. Let's see what we've got here. Let's have a look at distance sensor 2. Yeah, that seems to be working fine. Distance sensor 1. Fine. Distance sensor 3. Yep, that's fine. Distance sensor 4. There we go. I'm pretty impressed with that. That was vibrating the absolute life out of that thing for about an hour, and it's held up no problems at all. Right, now for some shock testing. Let's snap the end off it there, but the potting's still in place, the sensor's still inside. Well, I lined it up on the T-ball and gave it as hard a hit as I could, not pointing at the shed this time, and it snapped the whole thing out. That's just the connector on the inside. So what I'm going to do is fit that back in there and see if she works. Alright, distance sensor 1. Yep, still works. Distance sensor 2. Yep, distance sensor 3. And 4. Right, that is unreal. I honestly don't know how to kill it, besides now smashing the whole thing apart.